For the transistor circuit shown, if beta, that is current gain, is 100, the voltage drop between emitter and base is 0.7 volt, then the value of VCE, that is voltage across the collector and emitter, we have to find out. VBE is 0.7 volt, that is also given. Now you have to find out the base current first. Okay, base current first, that is, see, voltage drop between emitter and base is 0.7 volt. This is there. Now you apply the loop to this first. So that will be by KVL, that is Kirchhoff's voltage law, to the loop. You start from the negative of this VBB voltage, that is negative to positive, rise in potential 5. Then this is base current is set up here 5. In the direction of the current you are moving, so minus IB into 8.6 into 10 to the power 3. Then you are moving from higher to lower potential, hence drop in potential should be equal to 0. So 5 minus 0.7 is 8.6 into 10 to the power 3 IB. So this is 4.3 by 8.6 into 10 to the power minus 3 is IB, that is a base current. So the value of base current, this is 1s, 2s, 0.5 milliampere. 0.5 milliampere is IB. We got the value now. Similarly, now beta is given. Beta is IC by IB for a CE configuration, that is common emitter configuration. So beta is 100, correct? Beta is 100, IC I need to find, whereas just now I have calculated IB, that is 0.5 into 10 to the power minus 3. That implies IC will be 100 into 0.5 into 10 to the power minus 3. So this will become 10 to the power minus 1. This cancels with that. So IC will be 0.05 ampere, or it will be 50 milliampere. It will be 50 milliampere. Now I have to apply the loop rule again to this loop. This is called the output loop. See, output loop you have emitter common. Input loop you have emitter there. So for both input loop and output loop you have the emitter common. That is why it is called common emitter mode. Now to this loop, starting from here, this is negative, no, VCE, and then this is VCC, this is IC, this is the direction of the current, this is the direction of the current. So IC will come in this way. So VCE KVL to output loop we have to apply now. KVL to the output loop. So starting from VCE, so this is from negative to positive, rise in potential, so plus it is. Against the direction of the current, so plus ICRL, this is, I will take this resistor as a load resistor RL, minus 18 equal to 0. Minus 18 equal to 0. So VCE will be equal to 18 minus ICRL, IC into RL. So that is 18 into 0.05 ampere of current that is minus 0.05. Here it should be minus into 100 into 100. So now when we calculate, this is 100, this is 2 decimals, this is 5, it is literally 18 minus 5, that is 13 volt. So the voltage drop across the emitter and collector is 13 volt. Hence option C is the right answer.